Okay, today we're going to focus on graphing factored polynomials. So we're going to really focus on tying in the factored form of a polynomial and the zeros that you guys have been finding with zero product property and what the graph will look like as a result. Our objectives, students will be able to use the factored form of a polynomial to find the zero or zeros of a function. Some of the vocabulary that you might hear today: slope, linear equation, quadratic equation, cubic equation, origin, x-axis, y-axis, point, zeros, roots, x-intercepts, y-intercepts, multiplicity. And so we kind of look at our first example here and we think, graph each of the following polynomial functions. What are the function's zeros? Counting the multiplicity. If we've forgotten what multiplicity is, it's the number of times a solution occurs in your solution set. So you might need to write that down. What are the solutions of f of x equal to 0? What are the x-intercepts of the graph of the function? How does the degree of the polynomial function compare to the x-intercepts of the graph of the function? And so the best advice I can give you at the moment is to sign on to desmos.com, because this is an online graphing tool that will really help us as we continue graphing and begin to flourish in our understanding of the connection between the equation and the graph. So basics of graphing: you have two axes. You have a y-axis that goes up and down or vertically, and you have an x-axis goes horizontally. At each coordinate point, so again, you might have heard the word point in that list of vocabulary words, is a combination of x and y. So I might remind myself, one way I remember is the alphabet, x, y, z. So the x has to come before the y. The x goes across, the y goes vertically. And you can change the scale. So right now I have these really small boxes. It's not going to let me see what's going on with my graph very much. So I like to maybe skip count and have a box in between. You just have to be consistent. Whatever scale you pick, you have to do it every single time. 1, 2, 3, negative 1, negative 2, negative 3. Okay, and so I sign on to Desmos. I go in there, and in one of the rows, I type in x, parenthesis, x minus 1, parenthesis, x plus 1, parenthesis, that you can see here. And the result that I saw on the graph, I want to grab some very specific points, but I saw it hit the x-axis at negative 1, it hit it at the origin, it hit again at positive 1. It had this really, really nice sort of S-curve to it, which indicates to me that I'm looking at an odd degree polynomial because it has end behavior that goes in opposite directions. So there are all these clues in the graph, and we're going to sort of elaborate on them continuously as we go through the unit. I do notice, if I'm going to be really close to sketching it, that it didn't quite reach halfway up. So it kind of looks something like this and came down. And since this is just a sketch, these are all the points I really need to answer the questions that I have here. And now it asks me about the zeros, including the multiplicity. So my zeros, you can make yourself like a little chart. This is just one tool to stay organized. And so my zeros, as I'm looking at it on the graph, I notice that it's x equals negative 1, x equals 0, and x equals 1. Now when we talk about the multiplicity, it's how many times did they occur, and it hit only once for each of them. And you can tell that this is going to be once or an odd number because the line, the graph, goes through the point. And we'll see an example of when we have an even or a multiple multiplicity that occurs in an even amount in just a second. And so I've answered the, what are the zeros? What are the solutions of f of x equals 0? I should put in 0 for f of x, and I get x times x minus 1, x plus 1. I know from the zero product property that if I have a product equal to 0, that one of the factors must be equal to 0. So I take each factor, x equals 0, x minus 1 equals 0, x plus 1 equals 0, solve. And now I have the zeros. Awesome. So here are my zeros. Algebraically, if they want to know the coordinate points, 0, 0, 1, 0, negative 1, 0 are the x-intercepts. The final question asks, how does the degree of the function compare to the x-intercepts? Well, I noticed that this degree is a little bit hidden right now, but I could do a little bit of math, and I have x times. I notice that's the difference of squares. And finally, I get x cubed minus x. So I know it's a degree 3. There are 3 x-intercepts. So the zeros relate to the degree by being this same exact value. So in sentence form, the degree equals the number of zeros. And essentially, we've answered all of the questions here. Now, they're asking us to do this for a second one, and what I noticed with the second example is, well, each factor is the same. So how is that going to affect the graph? Again, I go to Desmos.com, I type in x plus 3 quantity times itself 4 times, and I get this graph that looks a little something like this. Very steep. Oop. Should actually be this way. I forgot I skip counted. So it looks more like this. Apologize. So ignore this initial part of the graph. And so if I'm thinking about what are the zeros, well, the 0 is x equals negative 3 with a multiplicity of 4. And this becomes really important because the person looking at the graph isn't really going to be able to identify the degree or any of the other information without being told the multiplicity just from the graph. But if I combine this, the 0 of x equals negative 3, the graph, and the idea that we have multiplicity of 4, I'm better prepared to be able to know that this has a degree of 4. If I put this in f of x equals 0, I get x plus 3, x plus 3, x plus 3, x plus 3, and this gives me 0 equals x plus 3 on 4 separate occasions. And now I see that x equals negative 3, x equals negative 3, x equals negative 3, and x equals negative 3. And the only x-intercept that I see, though, is negative 3 and 0. Well, this is kind of nice. So as we go through, and finally the connection is, how does the degree of the polynomial compare to the x-intercepts of the graph? Well, there's only one. But my degree is really a 4th degree polynomial. I can tell that by the number of factors. I can tell by the number of times I see x minus 3. I can tell that by the multiplicity. And so we kind of need to reword the last sentence that we had here, the degree equals the number of zeros, to the degree is greater than or equal to the number of x-intercepts of our graph. And so this ultimately is kind of the way we need to word it, is really important part of understanding the connection between any equation and the graph. So again, I would pause this, I would summarize it, I would really be able to answer what is the connection between the equation, the graph, the zeros, the multiplicity, what it looks like, the fact that I know that this is going to be an even degreed graph, by the way, that the end behavior is both pointing in the same direction. All of these details kind of combine into making a better understanding of our graph. Thank you for your time.